Okay, so what is it we're going to talk about?
We're going to talk about parsing. It's essentially the process of recognizing the shape of a particular input string. And the process of parsing comes about, it's not only a domain, it's something from computer science, but also comes from linguistics and can be generally used as a synonym to recognition or understanding some concept. In computer science, it's more to do with, and specifically in programming language, it's more to do with a specific component inside of what we call a compiler. A compiler is essentially a translator that translates one language, the language of the programmer, into a systems language. So a compiler needs to be able to handle inputs and have outputs. The compiler translates these, handles these two. So you have an input that is a string, any sort of text data usually. The first part in the compiler, the basic stuff that a compiler should do, is essentially parse the input. And here the string, let's say for example, needs to be able to be analyzed. And this has several steps. In order to handle the string in the best way for the system, you have lexical analysis of the string. So say you have a given multiplication, 50 times 10 equals 500. And this is a string. First, what it's going to have to do is lexical analysis. And here there's a particular reference to how humans can actually understand information. A computational interpretation of how we understand it would be to analyze each term. So you have the sentence, my dad is coming home, and you classify those into verbs, adverbs, nouns, etc. What the parser does essentially is do lexical analysis, which essentially means creating tokens. Tokens are each of the elements on the string. So 50, the multiplication sign, 10 equals 500, the result. And it needs to be able to do this because, end of the day, the string goes through a syntactical analysis. The tokens create some sort of data representation. And this data representation, in order to be able to be translated, it needs to be put through syntactical analysis. This is the part that's really interesting because syntactical analysis means in humans as well as in computers that you understand the string, understand the sentence, let's put it that way. Why is this important? Because semantics, meaning the actual outcome, what it means to understand a sentence, comes out of syntax. And syntactical analysis is basically done through a reference to context-free or any kind of grammar really. Context-free grammars usually. Meaning that if someone speaks to you in French and you don't understand French or don't have that module in your head, you won't be able to parse it. So that data representation will have some sort of representation, will be like a sentence. You can understand it through the being a sentence, but you won't be able to extract any kind of semantic content from the syntax of strings. You can say they are letters, you can say they are words, you can say it's a sentence, you can say it must have some content. Obviously with humans there's some ambiguity as they have like they can say this is a door, and you have the human pointing towards a door. So, but it's saying in French. Hence, you can do some abductive inference there and make sense. However, it doesn't mean that you are understanding the semantic content. And this is all a part of compilers. At the end of the day, the compiler does a semantic analysis after it's checked that the string conforms to the grammar inside of the system. And that's what parsing is. The thing about compilers and parsers, etc., and the difference between, I guess, humans is that while we can certainly take a computational angle and interpret our humans as essentially computers, and there are some similarities between how humans understand these things and how computers do, There is a crucial sense in which humans can tolerate ambiguity, can tolerate pragmatics, can tolerate different kinds of situations where informational content can be inferred. But in the case of computers, ambiguity becomes a matter of insecurity. And that insecurity in not properly parsing inputs because someone didn't design a specific parser to understand a given string based on a grammar, that creates a lot of vectors of attack for, let's call them black hat actors, because there are many ways in which a parsing error and a fundamental error in recognition of the string actually can create some pretty big errors, buffer overflows, and exploit programming. The more systematic way of thinking about this is essentially you can create buffer overflows with this, but you can also create what is called a weird machine, and I think we can go into that as well. But it's a fundamental mistake in not thinking through parsers enough as a specific and important part of compilers, and in a specific way in which computers handle that ambiguity that may prove to be insecure.
Now I've got the token, so I can load a value in, add the value from my register into it, and store it back and hand the token. And now I've got the token again, I can load something into my register, add something onto it, throw it back, and pass the token on. And I've got it, so I can load the value in, add the value from my register, store it back.